Now we want to look at some equations and go from polar world to XY world. So let's kind of progress our way through this with a couple of examples to end this section. So let's look at the equation in polar world, r equals 5. And we want to convert that to XY world. I'm going to keep in mind, again, these relationships I have right there and try to figure out ones that can be useful. This one right here is useful as I can multiply both sides or square both sides. And so I can have r squared equals 25. I remember what r squared is. R squared was x and y, so that's my goal, is to remove my r's and thetas and get my x's and y's. And so I have x squared plus y squared equals 25. And so there's the same equation from polar world into XY world. Another example that I want to look at is if I have theta equals pi fourths. There's an equation in polar world, and we want to convert that to XY world. One thing that's useful for me right now is this tangent theta. So I know that the tangent of theta equals y over x. The tangent, and the particular theta that I have is pi over 4, so the tangent of pi over 4, that's one of our 16 special angles that we know. So the tangent of pi over 4 equals, wait for it, equals 1. And so then I have 1 equals y over x. I can multiply both sides by x, so I got x equals y. And so there's the equation in XY world of the equation x equals y. And if you remember that equation, it's a slashed line that goes from the first quadrant through the origin into the third quadrant. And so there's two examples, polar world to XY world, polar world to XY world. All right, another example that we have in polar world is r equals 3 cosecant theta. It obviously looks like it's in polar world because my variables are the polar coordinates. We want to get that to XY world. I know that cosecant is the inverse of sine. So 3, or the reciprocal of sine, excuse me. So I can rewrite it as such. I know what sines and cosines are more easily than cosecants. I can multiply both sides by sine over theta. So I have r sine theta equals 3. R sine theta, wait. I know what that is. That's already over here. R sine theta is what my y value is. So I know I have y equals 3. And there's my xy equation, or my equation in XY world. The line y equals 3 is equivalent to the polar equation of r equals 3 cosecant theta. How are you guys doing? Doing all right? Take a little bit of breath here. Shake it out. All right, let's do the last one that I have here. It has a few more steps involved. So I have r equals -6 cosine theta. Again, it's in polar world. We want to transition it to XY world. And let's start doing some things that we feel like we can do here. I think the one thing I can do is I have cosine theta. I'd love to have if there's an r in there. All right, so let's multiply both sides by an r. I have r squared then equals -6 r cosine theta. That's good because both the r squareds, I know what that is, that's x squared plus y squared -6 r cosine theta is an x. Not bad. I'm feeling pretty good about it. All right, let's go ahead and solve that out because I can't leave it in that form. It just does not look right because I have variables on both sides of the equation. No good. So let's go ahead and subtract or add 6x to both sides. So 6 or x squared plus 6x plus y squared equals 0. I can do more. I'm going to add a 9 to both sides. X squared plus 6x plus 9 plus y squared equals 9. The reason why I'm doing that, it will become apparent on this next step because this right here looks like a perfect square. And this is the square of x plus 3. squared plus y squared equals 9. And I wanted to end up right there because I remembered that was the equation or the standard equation of a circle. And so I'm able to go ahead and transition this equation from polar coordinates, work through that, look for some opportunities to insert and transition, and I wind up with an equation that's a little familiar to us. It'll become more familiar as we continue our practice, but that's the equation for a circle in XY form. So there we have it. That was a little bit of a brief review on this section of working through polar coordinates.